Hello, welcome everybody. Oh wow, this is echo. Okay, so this is the last talk of the day, so I'm very happy that so many of you showed up. This is also pretty much of a niche talk, and it's also slightly schizophrenic because basically I've been doing several different things on App Engine, and this talk is going to be about what I've done, basically. The main focus is going to be JRuby, but I'm also going to talk a little bit about something called Ioke. And that's about it for introductions. Well, actually, I'm going to keep this a little bit short, so we have lots of time for questions afterwards. And I'm also informed that this is the last talk of the day, so the shorter this talk is, the sooner people can get to their beers. So I work for a company called ThoughtWorks as a consultant, programming language geek, whatever. I spend lots of time with JRuby. I'm one of the core developers for JRuby, and I'm going to be talking more about what JRuby is soon. I'm Swedish, so if I pronounce something very weirdly, that's because I'm not a native English speaker, so just so you know. Anyway, I've written a book about JRuby a few years back, and I've been spending lots of time in the Java and Ruby communities, especially the last few years. And that's about it. ThoughtWorks is a global consulting firm. We have offices all over the place, including here in San Francisco, about 1,100 people. We have invested quite a lot of time and money in Ruby, and we actually did a lot of Ruby work in 2007. We're the largest Ruby company in the world, actually, so that explains a little bit our interest in Ruby and other kinds of technologies like that. We also are famous for Agile. We spend lots of time in open source. Chances are if you have used any open source tool, you've probably used code that someone from ThoughtWorks have contributed. Martin Fowler is our chief scientist, and that's actually the main reason we're famous in many circles. We have something called Studios, which is a product division. And these products are all really cool. They solve problems for most development teams. So I urge you to check them out. Okay, so how many in this audience knows Ruby? Oh, wow, that's perfect. That's almost everyone. So I'm sorry for the rest of you. If you don't know Ruby, try to follow along anyway. I'm not going to, I think I have, if you want to know what Ruby is, read this slide really quickly. Or rather, well, it's pretty interesting. The one thing that I find interesting about Ruby as a language is that it's actually older than Java. But it's sprung out on the scene of common knowledge the last few years thanks to Rails and other things like that. There are some features of Ruby that you should know about if you don't know Ruby. These are the main ones in my mind compared to Java, for example. And let's see. These are basically some of the main things that I'm going to be talking about, just so you don't get totally lost. Ruby Gems is the package management tool. Rake is the build tool, and you can also use Rake for doing lots of other things. RSpec is one of the standard testing tools. Rails and MERB, web application frameworks. Romaze and Sinatra, also web application frameworks. And that's it about pure Ruby. How many here have played with JRuby? Okay, so that's about 30, 40%. So I'm going to spend some more time introducing JRuby. Basically, JRuby is an implementation of Ruby. It's as compatible as we can make it on top of Java. It runs on Java 1.5 and upwards. It's an open source project, and it's compatible with Ruby 1.8.6 specifically. We're adding Ruby 1.9 features. They're not complete yet, but we're trying to add them as good as possible. The current version of JRuby is 1.2, and we actually just yesterday released our second release candidate of 1.3. And 1.3 is going to be the JRuby version you should be using if you want to use JRuby on Google App Engine, for example. We are going to release the final version of 1.3 next week at Java 1. So one thing I want to spend some time on is why JRuby? Especially since almost everyone in the audience actually knows Ruby, this question is a little bit more pertinent. What's wrong with the regular Ruby interpreter? And I'm not going to say everything is wrong with the regular Ruby interpreter, but there are many things that could have been better and things that actually cause lots of problems for people trying to do things on MRI. The first one is threading. So MRI is green threaded, which means that all threads belong to one operating system process, which means that you can't really use any cores if you have that in your system. You have to spawn new threads, new processes to actually use new cores. In JRuby, we solve this by using Java threads. So a Ruby thread is a Java thread, and that's basically it. So threads are a little bit cheaper on MRI, but threads actually can help you scale on JRuby. That's kind of the trade-off. Ruby has traditionally been very patchy in its support for Unicode. And if you want to use Unicode and do some kind of multilingualization or anything that works outside of the US, you're going to have to use some pretty hairy techniques in many cases. And they don't work all over the place. So the implementation has been patchy at best. In JRuby, to be compatible with Ruby, we had to actually mimic all those bad things. But we also give you access to Java strings. So you can actually use Unicode the way Java allows you to do that from JRuby by using Java strings instead. Ruby enthusiasts generally say that Ruby is fast enough. And fast enough in that definition is still enough to put you at the slowest place in the comparisons between different dynamic programming languages. JRuby is between 2 and 10 times faster, depending on how you measure. In average, you're seeing between 4 and 5 times the same compared to MRI. Compared to 1.9, we are in most benchmarks a little bit faster, in some benchmarks slower, and in some benchmarks very much faster. So we are actually setting our goals against 1.9 right now. The reasons we are faster, there are several reasons for this. The first one is that JRuby has both an interpreter and a bytecode compiler. And we actually switch from interpreted mode to compiled mode per method. So if you have a method that really gets called a lot, we compile that down to Java bytecode. And then Java takes Java hotspot basically takes those bytecodes and profiles them and turns them into very efficient native code where it's needed. So we get pretty good performance, actually. Any medium to large Ruby application will leak memory because the MRI garbage collector is a very naive implementation, and it leaks memory. That's basically fact. JRuby uses all the garbage collectors in the Java, on the Java implementation. So that means that basically we just get the same kind of performance as Java applications get from and the same kind of memory benefits. You can also use the same way you tune a Java application to tune your Ruby garbage collection. There are 4 algorithms in Java right now, and there's going to be a new one in Java 7 that makes garbage collection really, really even better than it is right now. If you can see the trend here, the trend is basically that we use the Java ecosystem, we use the JVM. We don't really do anything extra in JRuby to support these features. They're just there because we are on the top of the JVM. C extensions are really annoying to write for Ruby. In JRuby, you basically write a Java extension instead. A Java extension avoids many of the problems that you have when you write a C extension for Ruby. A few of the examples of things that can go wrong when you write C extensions is that, first of all, you can bring down the whole interpreter. Secondly, there's no well-defined API for how you work with the MRI interpreter from C. So the C extensions can do basically whatever they want. That's really powerful, but it's also very, very harmful because the interpreter can't really be safe that anything in its internal systems is going to be unchanged. So with JRuby, we basically just allow you to use Java classes. And since we are implemented JRuby in an object-oriented system, we get encapsulation and interfaces for free. And additionally, in JRuby, you generally don't need to write Java extensions. It's basically 1 case in 10 of the cases where you write C extensions where you in JRuby need to write a Java extension, because in most cases you could just use Java code directly from Ruby. So JRuby allows you access to any Java library out there. We can use anything, and it's very nicely integrated, so you just use it. It works. I'm going to skip over those. So it's very easy to get started with JRuby. You have to have Java installed. I guess that's pretty common in this audience. You download the tarball, and then you get JRuby. You get the Ruby standard library, you get Ruby gems, and you get Rake. And then you unpack it. You can have multiple copies anywhere you want. And the only thing you need to do if you want to be using JRuby from anywhere is to have the bin directory on the path. And then you can start installing gems, for example. If you only have JRuby on your system, you can do gem install rspec. But if you have several different Ruby implementations, you should use JRuby-s to specify that you want the gem version for JRuby and nothing else. You can also call out to Ruby from Java if you want to. This is with the Java 6 script engine manager. And it's basically very, very simple code. You get the engine by name, and then you evaluate it. And that's about it. It's not that hard, actually. There are also support in the Bean Scripting Foundation to do these things. And you can call out to the JRuby engine directly if you want to. Depending on your needs, these three versions solve different problems. So JRuby, as I mentioned, allows you access to any Java libraries. We call that feature Java integration. Basically, Java types looks like they are Ruby types. You can do anything you can do on a Ruby type, you can do on the Java type. So you can call methods, you can construct instances, you can pass those objects around, etc. We also, since Ruby uses snake case in this library, and Java uses camel case, so we try to switch. So when you code against a Java library, you can use either snake case or camel case. The transformation is canonical, and we won't do it if there are existing methods with that name. But this actually makes your Java code, or the code using Java, look much more like Ruby, which is sometimes a good thing. JRuby can implement interfaces and also inherit from classes. We have something called closure conversion. In many of those cases where you have an anonymous class implementation in Java, you basically just want to have that implementation, send it into something. In that case, it's just boilerplate to have to write the name of the class or interface, the name of the method, and all that stuff around it. So with JRuby, if you send in a block to one of those methods to take something like this, it will just turn the block into an implementation of that interface or an extension of the class in question. This makes some code very, very terse compared to the general case. I'm going to show how what these features look like. We also have added some extra features to Java classes and interfaces to make them much easier to work with. We can add any kind of, since Ruby has open classes, we can add anything to Ruby classes. That means also that we can add any new method we want to a Java class too. So I'm going to show you a little bit what our Java integration looks like. And I'm going to be using, let's see, here we are. JRuby, which is the interactive Ruby prompt for JRuby. And it's basically the same as the interactive prompt for regular Ruby. Can everyone see this? Is there someone who can't see it? Okay. No answer at all. I can do 1 + 1, etc. I can also use a Java class. And say, hello world, in a slightly more verbose way. I can import classes, but importing a class doesn't really do exactly what it does in Java. In Ruby, import basically does exactly the same thing as doing hashmap equals Java util hashmap. So it just sets the name in the local scope. I can use that hash map. So I can create a new hash by calling .new. And I can add stuff to it. Like this. As you can see, we have added index, or the square bracket, so you can work with these with a hash like it was a Ruby hash, while it actually is a Java hash in this case. As you can see, if we print it, you can see that it says that it's a Java util hash map. And the name on the left-hand side, that's a canonical way we refer to Java classes. In most cases, it's easier to refer to them in other ways. But if you really want to understand what we're doing with the Java integration features, that's the way you get access to it. we can see that this is still a Java object, and if we call 2s to it, we can see that we get the hash map way of printing this stuff. So we can work with this just like it was any Ruby class. And we have added lots of other stuff. So, for example, Java util list is enumerable. So you can use all enumerable methods on Java lists and so on. You can also get access to other APIs. So Java Security, for example, has this funny method called getAlgorithms. Now, I did something interesting a few years back when I was working on creating a Java-based implementation of OpenSSL. Using the Java security APIs instead of the primitives on OpenSSL. And I needed this getAlgorithms method all the time. And the problem with it is that getAlgorithms doesn't really describe what the result looks like. So I have to basically create lots of small test classes to see what I get back from calling this in different ways. So instead of creating those small classes, I instead open up JRuby's IRB, and I call the method from it here, and I can just see that in this case, I get algorithms that looks like this. And I can modify them and work with them like I could with any Ruby class. I can sort them. I can grep for a specific algorithm, and so on. This is mostly useful for Java APIs that have bad documentation or documentation that doesn't tell you anything. For example, if you want to check for corner cases in the regular expression APIs for Java, this is a perfect place of handling it. I used to have a spikes directory where I had like 100 Java classes that were just 5 lines long to do stuff. I don't do that anymore because I can test all those things in the interactive prompt instead. Now, those examples were a little bit useful. So I'm going to finish by showing a slightly more useless example. But it's very flashy, or a little bit flashy at least. Since I can work with any Java APIs, that means that I can, for example, work with Swing. Let's see, create a new frame here. This is going to take some time because I'm running on the Soilat, so it needs to start X11 in the background the first time. Sorry about that. And there we get X11, and now we can set the size, and we can show it. And here I have a swing frame that I've created dynamically. Now, everything is not over. I can actually work with this swing frame. So I can create a new J button, for example, that says, hello, world. And then I add that to the frame, and then I show the frame again. You can see we have this beautiful button that covers the whole thing. It doesn't really do anything, but that's OK, because we can add behavior after the fact. This is not static, right? So we can add an action listener. And my problem here is that I never remembers what the interface is called. And I don't really believe in IDEs that remember stuff for me, because if it remembers for me, it can write the stuff for me. And that means that I will be writing lots of code that I haven't actually been typing, which means that I will have to read that code later on. And that's the step that I really dislike. So since I don't remember the interface, or actually I think I do remember it, but anyway, the code for implementing this interface would be a little bit annoying. And I don't really care. The only thing I want to do is do something when someone pushes this button. So in this case, I'm just going to say, give it a block. And I say, button pressed. And end. And then I go here. Now you can see that we're triggering Ruby code from a Java Swing interface here. I can also add a new action listener that can do some stuff here. E is the event. An event has this method called source. Actually, the method name is getSource. But since this is Ruby, and the Ruby convention is to not use get in the names, JRuby actually adds aliases. So just doing .source will invoke the method called getSource. The same thing is done with text, with setters. So there is no method called text equals on the button. Instead, there is a method called setText, but this does exactly the same thing. So I can modify this interface, and I can go back here, and when I press it now, the text changes. So that's a very, very small example of how you can work with Ruby code and Java code and just mix and match and do whatever you in different pieces, exactly what you want to do. The key thing to remember is that you can do anything you can do from Java, you can really do from Ruby. as long as it makes sense, so to speak. There are a few, there are a few caveats to that. The thing is, some of the things that you want to do, in Java doesn't really make sense to do in Ruby. A typical example is annotations. Now, annotations are really useful, but they're a static feature. And since JRuby is running at runtime, it's already too late to add those static features when the Ruby program is running. So annotations doesn't actually make sense for a Ruby program, or at least Java annotation doesn't make sense for a Ruby program. Another typical thing is generics. Ruby doesn't have generics, and the JVM doesn't have generics either. It's just the Java language that has generics. So there is no syntax for working with generics because it doesn't really make sense to work with the APIs at runtime with generics since they don't exist at runtime in Java. Okay, so let's switch over to Rails a little bit. I assume that everyone here who knew Ruby actually knows Rails too, so I'm going to just skip over these, really. But this one is a little bit more interesting. So Rails works perfectly on the JRuby. It's very easy to get started and set up. It's basically the same thing as starting out a Rails application with regular Ruby. The only thing you need to do differently is to use a different active record driver for the database because you can't really use active record. Instead, you need to use something called active record JWC. That allows you to use JWC to back your Rails application. We have very good performance and lots of deployments of JRuby. And you get access to all the libraries in Java. You can create a Rails application that uses EJBs and so on if you really feel perverse. It's very easy to deploy. The Rails deployment story has for a long time been a little bit annoying. This is getting better, but in the JRuby world, it's very, very easy to deploy. Basically, you just package your Rails application into a WAR file, and then you deploy that WAR file exactly like you would any Java web application. JWC allows much better database support than Rails does in general. And it's also totally platform independent. So you can run, this is one of the examples that we have. I find this pretty nice, actually. I'm sure you couldn't do that with regular Ruby. Okay, I said earlier that JRuby is compatible with Ruby. That was a lie. Or a truth with modification. Basically, there are a few things that doesn't really work or that we have changed. The obvious one is that you can use Java classes, but that is no real change in syntax. The only change there is in libraries, and you could, if you really want to, you can use the Ruby Java bridge and implement the same API, for example. But JRuby is still the most compatible alternative implementation, and it's the only one that runs basically all Ruby applications. Native threads versus green threads generally doesn't make a difference, except for in a few special cases. Many Ruby libraries depend on unsafe things. And the reason they do that is because it's safe to do them when you have green threads, because they have a deterministic scheduler. We can never guarantee that kind of thing with native threads. So some of the libraries, for example, timeout, is a library that is a little bit evil to use at all. So C extensions are not supported right now. We're working on that, and we should have support for it in a while. It's a little bit tricky to provide support for C extensions from JRuby, not because it's hard to call out to C, but the thing is about the C extensions is that they, as I mentioned earlier, since the Ruby MRI interpreter doesn't really have any good interface to its internals, the C extensions, they do all kinds of really nasty things, which means that for us to be able to support that, we need to fake out those things so that the JRuby stuff looks like they have the same internal structure as the Ruby implementation. That's not entirely trivial, but we're working on that. We don't support full continuations. No one has really complained about that. We don't support fork. Well, actually, we have fork. Fork is working, but we have turned it off because it's not really a good thing to fork your WebSphere or whatever in production. I think that people was going to be a little bit mad if some library does that. Object space is turned off by default. You can turn it on if you want to. It's going to cost you about half your performance if you do it. And there are generally better ways of doing stuff. Okay, so I mentioned it's very easy to package things. Basically, you need something called Warbler. It's a self-contained thing that includes JRuby and a servlet adapter. And you do JM install Warbler. Then inside of your Rails application, you do warble config. And then finally, you do warble. And at that point, you have a war file. Rack is one of those APIs that people are using to provide uniform access to different web application APIs. How many here knows about Rack? Okay, so that's about 50%. That's pretty good, too. Basically, all Ruby web frameworks support Rack now. And we have something called JRuby Rack, which is a Rack servlet. It's basically a servlet that dispatches to Rack. So that means that any web framework that supports Rack can be used with JRuby Rack. And it handles pooling and stuff like that, too. Okay, so I have spoken for a while without coming into the Google App Engine stuff. That should hopefully change now. So JRuby works fine under Google App Engine. People have tested several different web frameworks and so on. It's still a little bit, there are still a few things that makes this not totally trivial. It works more or less as you would expect it, but it's a few things you need to keep in mind. Some of these things, so Reggie is basically a library that tries to take care of some of these things. It stands for Ruby Enabled Google App Engine, and it provides simple support for configuration, packaging gems into jar files, simplify the running of Rack application on the local development server. The local development server is, I think I have a slide for the problems, but the local development server is a problem in general because it doesn't really mimic exactly the Google App Engine that you upload stuff to. So if you run your unit tests locally on the dev server, that doesn't really mean that will run the same on the Google App Engine stuff. So in principle, you should be able to use the local dev server. In practice, I stopped doing that because it didn't really work. So that makes it a little bit annoying to, you don't really have the quick turnaround that you would expect from a Rails application. So you need to deploy to test, basically. Reggie tries to fix some of these problems. I don't know how far they've come to that. It's supposed to also help with deployment, but it's not really done that yet. And it could probably need some really good Ruby hackers to help out. For interacting with the Google App Engine APIs, we have, for example, we have DataMapper. DataMapper is a Ruby ORM that have support for lots of different backends. And it actually has an adapter for BigTable. It's called DM Datastore adapter. It doesn't support everything DataMapper supports, of course, because basically, DataMapper is a full ORM tool that's supposed to support everything you can do to an RDBMS. You can't do that on Google App Engine, so it only supports the kind of things that you actually can do with BigTable. Another one of those libraries, and this is a specific one, this is just like 10, 20 lines of code, but it's enough. It's a library called BU that allows you to integrate your Rails application with the user service. Basically, you get person and admin status automatically set. It's very, very easy to use. I'm actually going to show this code later because, yeah, I have a Rails application that I'm going to show you. Oh, let's see. Okay, let's kill X11. Sorry. Okay, so the actual application, first of all, looks like this. It's a very, very, very simple blog post thingy. And let's see if it actually responds to me. The first request is kind of slow sometimes. So I can create a new blog here. I can go in and add new posts, for example. And look here, the fact that I'm logged in here, I can log out. And the way this works is that if you're logged in but not an administrator, you can add comments. If you are logged in but is an administrator for the AppSpot stuff, you're able to post new posts and remove stuff and so on. And this is all using my Gmail account. So the integration is dead simple, really. Let's see if this. Okay, This takes time. Sorry about that. This is basically just the single sign-on stuff. And now I'm back at the start again, so I can go back to the front and so on. And you can see here that I don't have access to remove stuff and so on. This code is very, very simple. It's more of a proof of concept than anything else. And it's actually, you can download the code from my GitHub account. But I'm going to show you a few of the pieces that actually, the things you need to do to make a Rails application run. So first of all, it's pretty simple. You need App Engine XML. And you need a Datastore indexes to be able to do joins. This stuff is all pretty much documented. This one sets some properties. Actually, these are, except for these two are the only properties that you need to do for JRuby right now. The rest of them are actually the default ones, I think. But this is just basically exactly the same thing as it works in the for the Java stuff. Warbler, you need to specifically include the App Engine web and Datastore indexes files. And you need to, actually, you can actually set this down because you're never going to get more than one runtime anyway. And you need to make sure that no Java libraries are included in this way because you need to add all your Java libraries yourself. So in this case, you need to have App Engine API, and you need to have JRuby. And you need to have JRuby Rack. And those, all of them can be found on the net in a pretty simple, with one of those very nice search engines we probably know all about. Okay, so configuration-wise, this application is pretty simple too. The one thing that it does here is that it actually requires BigTable servlet store. I created my own servlet store to store sessions in BigTable instead because I found that the way sessions worked are a little bit tricky on Google App Engine. I'm removing active record. I don't need active record at all. And then finally, let's see, what do I do here? I set the BigTable servlet store, and I require something called Bumble. Bumble is also a very small project to basically give you something that looks like the active record but uses BigTable underneath. So let's take a look at the actual model files first. These ones all use Bumble. And this is the way you work with them. DS describes the properties you want to be using. You need to do this to get automatically generated properties so you can work with this. You can still add new stuff to these exactly like you would with BigTable with the core APIs. But this is how you get some nice accessors. You can say belongs to and has many. This one says that the order should be inverted, created at, for example. Let's see. A person has a given name, a surname, an email, has many blogs. And finally, a post has a title, content, created at, and blog ID. And that's basically it. It's a very, very simple model. So when I go into the blogs controller here, you can see this looks more or less the same as you would do in regular active record. The start action fetches all the posts by doing post.all and limiting to 15 and inverted order from created at. This one gets all the blogs. This one gets a specific blog by ID. This one gets a specific post, etc., etc. You can see that we can refer to .blog, etc., just like you would expect. Creating new things you can do in the same manner as an active record with blog.create. Nothing really fancy there, actually. All of this stuff more or less works like you would expect it to do, actually. Post.delete, post.all each, etc. BU. As you saw, the whole way when I used login and so on, that was actually provided by BU. And I use it by doing include BU here. And then I assign user and admin status. And they will set instance variables with these values. And then I also have this assign person filter that will, if a user exists, we'll try to find that person in BigTable. And if we don't find a matching person for the user, we'll create a new one based on the information from the user. This is actually the user interface. So this is actually Java code I'm calling out here. But you can't see it because it looks exactly like Ruby code. And in the blogs, I can have security by saying require admin and just name the actions that need admin security. And that's all I need to do to make sure that these don't show up and so on. So this application is really, really, really simple. This is really all it does. It could do some more stuff. I have a test controller where I added some new stuff. This is actually commented out. I have a rendering of some simple stuff. And I also have this Ruby action that actually will instance eval new stuff. So you can test anything on the server. Finally, I have something called run tests, because I created a small test framework called Ioke test. And Ioke test allows me to first publish the application to the server, and then run tests on the server instance, and then get the report back into it. The reason I needed that was basically because I needed to do unit testing on the server, and none of the RSpec or test unit of those had support for doing that kind of thing. And I think that's really, really all I'm going to show from this application right now. Yeah, OK. So that was the Rails application running. As I mentioned, it's just, take a look at my GitHub account if you want to see the code. It's nothing complicated at all. There we are. OK. So I mentioned that Sinatra works. It's a very small DSL for writing Ruby web applications. And the simplest thing you can do looks like this. Using Warbler, you can package this up using JRuby Rack, and you can just use it. And it's going to work more or less exactly like running it locally. Romaze is also a very nice web framework that runs on a rack and works with DataMapper. Right now, there is this problem with threads. As you might know, Google App Engine actually restricts you, so you can't really use threads. So any library that needs to use threads need to be patched. And there are some other limits that you need to keep in mind when doing a Ruby application. The first one, there are a few limits on files. You can't have more than 1,000 files in your application. Of course, this sounds like, well, of course, that's not going to be any problem, right? Until you freeze all the Rails gems into your application. Since you need to freeze these gems, you will actually end up with like 800 files just from freezing those gems into your vendor library. And then you get a few more files after that. So that 1,000 files, you need to use a specific, there's a gem for packaging gems into jar files that you can use. And you also have a restriction on how large jar files can be. And especially in the last version of JRuby, the JRuby complete jar file was actually larger than 10 megs. So you need to split that one. Reggie is supposed to help you with those kind of things. We don't really support the image API. There is something called image Google App Engine that you can use to get around. Because there are image APIs in Google App Engine, but they are not really standardized. And they don't really work with JRuby out of the box. Well, you can use them as Java libraries, but there's no Ruby support to do it. As I mentioned, no threads. This is going to be problematic in some cases because Ruby actually uses threads in some very strange places. As I mentioned, timeout uses threads by default. Actually, JRuby has replaced that, so we don't do that anymore. But there are thread usage all over the place. So if you get strange errors or exceptions in your logs that complain about threads, that's because you can't use threads, basically. You can't even write to files either. So if you have anything that depends on being able to write to file, you're going to have some trouble with that. One of the things that will bite you in JRuby is that reflection doesn't work on everything. So for example, you can't call specific methods on objects, for example. You can't do set accessible on protected methods and so on. So if you want to do really weird stuff some of the weird stuff you might be able to do with JRuby, you'll hit in some limitations because of the reflection stuff. The biggest problem of them all, though, is the startup time. Because right now, the combined startup time of JRuby and Rails is actually pretty large. It's like the first request to start up a new JRuby runtime takes almost 15 seconds. There are ways to get around that, to get that down to something like 7 or 6, but it's still a problem. And we are actually, I've been talking to several Google engineers, and we're trying to figure out a way of solving this. But the problem is that the way the Google App Engine architecture works is that well, basically you have no shared state, of course, so you can't share engines. So every concurrent request is going to need its own JRuby runtime. I don't really have a solution to have to solve that right now. One of the ways you can get around it right now is to use something that is not Rails. If you use Ramesh or Sinatra, they're going to be much smaller, so they're going to load much faster. Testing is really problematic, as I mentioned. Local testing, I have had no success at all with local testing, actually. You can do unit tests of your implementations if you disregard all the Google App Engine stuff. But basically, you need to run the functional tests on Google App Engine to be sure. So one of the ways you can do that in building in testing triggers into your application, like I showed you with the Ioke test stuff, you can do that. Or you can use something like Selenium to do just black box testing of the user interface. One of the ways that you can do to make this happen, one of the good things about Google App Engine is that you can have several versions running at the same time. And they will be totally separate from each other. So you can deploy to a test version that you will never make the default version, and then you can test against that. And you can also have different staging environments and so on. That's one of the good things of having an environment where you basically can start up new things and spread them around. So that's very good, and that makes it possible to test these things remotely, even if you don't get the same kind of instance feedback that you want if you're doing local unit testing. So Ruby right now runs on Google App Engine. There are some caveats, but it runs, and there are efforts underway to make it even easier to use it. Ioke is something totally different from Ruby, actually. The only thing it shares in common is that it's an implementation, or actually it's a programming language that runs on top of the JVM. It's an experiment. It's dynamically, strongly typed, prototype-based object orientation, homoiconic language, inspired by several different languages. Let's see, and that's basically it. Ioke is a pretty different language, so I'm going to very, very quickly show you what it looks like so you get a feeling for it. So let's see here. Sorry, I'm just going to... Okay. So as I mentioned, Ioke, it's really, it's an interesting thing. It's an experiment to see how expressive a language can be. And one of the ways that it's working against other things is the fact that if you make something more and more expressive, your language is going to get slower and slower. So Ioke is a pretty slow language compared to any other language. But it's pretty nice. So basically, the main difference between other languages is that Ioke uses spaces for calling methods. So the above would have been the equivalent of doing hello dot println instead. The dot in Ioke is actually the statement separator, so the equivalent of semicolons and so on. You can do most of the things you can do in other languages, 1 plus 2. You can create a new method called foo that takes an argument called x and then return x times x, for example. And I can call that by doing something like that. I have decimal numbers and fractions that are exact. I don't have floats because if you want to use stuff that needs floating numbers, you should use a faster language anyway, basically. It's having floats in the language is one of those things that are really, really bugs me because most programmers use them the wrong way. I just decided to take them away. Okay, so I haven't really shown you much of the language, but the main thing to remember is it's a very uniform language. It allows you to work with the AST. So you can actually change the running code while it's running. So you have macros of different kinds, syntactic macros and so on. This makes the language very interesting to understand in some cases, but it also makes it very, very powerful. Okay, so let's see. ICANServe is something very, very small. It's basically an Ioke equivalent of rack. It's a small Ioke servlet that dispatches to Ioke code. You create a file called IKS application.ike, and then you define your actions there. It looks very much like Sinatra, but it's not as fully featured. A typical example here, actually, this is an HTML builder that just allows you to output HTML by writing Ioke code. I'm going to be using that too. Okay, so Ioke runs on top of Google App Engine with the I can serve stuff. Basically, it looks, let's see if it's still up. You never know. Okay, here we go. So iokefun.appspot.com basically has 3 different actions. If you go somewhere it doesn't know about, it will just say really nothing here. If we go to foo, it will say, yeah, exactly, that's what it says. Sorry about that. Let's just skip that and look at the code for the actions instead. Of course. So basically, the only thing I need here is the IKS application thingy. And here I say action for path, and then I give a regular expression that starts with foo, and then I say hello world. Actually, you know what I'm going to do? I'm going to do something that I probably shouldn't do, but let's try it. I'm going to try to deploy this thing again and see if that solves the problem. But I'm going to do it in background. This should take exactly 2 more seconds, something like that. Now you can see a full live deploy, though. That should be very exciting for you. Anyway, so basically what you give to action for path are just methods, stuff that you can execute. Ioke is very it's expression-based, so everything returns a value. And when you call the method, you get a new method object that you can work with, right? And in this case, action for path foo will just return. Basically, what this code returns is what is going to be rendered. So this one will return hello world. This one will return you requested this, and then take the request path info. And finally, this one will create an HTML interface with the title nada, and then in bold, really nothing here. And you saw that earlier. Oh, sorry about that. I need to switch JDK. I was very close to showing you my, my password for everyone. If you're using Java 1.5 to deploy stuff, you can't really hide the password. That would have been perfect. Okay, so I think this I've done many bad things while doing live demonstrations, but I think that would really have taken the prize. Okay, so let's see if this one comes up now. Hello world. Okay. And here, this one is the one that actually generates HTML. So you can see that there's a connection between what happens here and what I have running over here. It's nothing fancy. It was more of a proof of concept that you can actually take another language that doesn't have a mature infrastructure, and you can just deploy it, and it works. Okay. So that was supposed to be very close to the end. I didn't have any more demonstrations. But then, as it happens, a friend of mine at Google, Jon Tiersen, managed to get me an account at Google Wave earlier today. So I decided to create something with that. Let's see if this one works. Okay, so here we have my Wave account. Let's see if I can resize it. So, okay, so down here, I have something called Ioke Bot at appspot.com. That is a robot. In the keynote, you saw that they were talking about robots for Wave. A robot is basically just something that can go in and participate in the conversation with you. So in this case, I can create a new wave to the Ioke bot. I can say hello, and this takes a little time before it gets back. And here we get, let's see if I can resize this so I can get a larger. Hi from Ioke. So this one is actually live. It's running on AppSpot right now, and it's running Ioke code that can interact with Google Wave. I'm almost certain this is the first third-party robot anyone has created for Google Wave, because I spent some very interesting hours earlier trying to get this working. It's actually very, very simple to do it, though. There are a few things you need. Basically, you need a directory in your WAR file, _wave, that includes capabilities.xml. This one says that we only want to know when participants change. That's the only event we're interested in, and the profile name should be Ioke Bot. Then the code itself, actually, let's go into App Engine Web, looks like this. And Ioke Bot is org.thoughtworks.iokebot.iokebot-servlet, and I basically just mapped that to this specific URL, which is the URL where Google Wave will look for robots. And you can actually see that if you go to this URL on, let's see, where? Ioke Bot. And we can go to that URL. You can see that in this case, we're going to get this network is really terrible. You'll get inappropriate because it always expects posts. And I don't really know the binary format for it anyway. But anyway, so this Ioke Bot is extremely simple. What it does is that it just gets an Ioke application, evaluates, loads Ioke code, and then injects the robot message bundle, and then calls dispatch. So if we look at the Ioke Bot code, you can see what's happening here. Dispatch is basically a method. First logs to the servlet context, logs dispatch, and then we check if events was participant added to Wave, and then our name. This basically just checks that, okay, the only time we want to do something is when this robot is added to a conversation. Then we get the wavelet, append a new blip, and get a text view for that blip, and finally we say, hi from Ioke. And that was exactly what happened here. So that's actually the whole story. It's very simple to do this. And I was very happy when I managed to get that working, actually. I'm one of those persons that like shiny things. Another thing about shiny things, I'm not sure if you noticed, but the Google Wave team seems to have a good, healthy knowledge of the Firefly series. You can see it all over the documentation and their error messages. It's really cool, actually. I'm a fan of Firefly myself. Okay, so alternative languages on the Google App Engine. I think that the important thing about Google App Engine, the Java support for it, is not the Java language, because the Java language doesn't really give you as many possibilities as you can do with all these other languages. You get automatic scaling, of course, but they get harder to test. Some of the languages work pretty bad because of the security restrictions. Reflection and threads are the main ones, file system too. But they still work pretty good anyway. We have done experiments with several languages, including Clojure and Scala, and also the regular Java stuff. And they are all viable ways of getting stuff out very, very quickly. It's really well suited for it. And it's funny, the Ruby web frameworks, there are several people actually deploying or thinking about deploying real applications in production on top of Google App Engine, which is pretty nice. It's also interesting to note that the JDO and JPA things that Google has put on top of Datastore actually doesn't really mesh that well with the way BigTable works. And that's one of the reasons that I didn't use the DataMapper APIs for these examples, because I feel that at a lower level, closer to BigTable way of working with the data is actually much better. Because a dynamic language like Ruby allows you to work with dynamic new keys, and that's exactly what BigTable allows you to do. So I find that the mesh of a dynamic language with BigTable is actually much better than the Java versions. So since you can use any language, there are about 200 different languages for the JVM. You can use most of them, as far as I know, on Google App Engine. Google App Engine allows you to do polyglot programming, where you have several different things implemented in different languages, and I think that's really, really nice. And it also allows you to think in a more service-oriented way. I definitely don't recommend people to put all their stuff in one application on Google App Engine. I mean, decide what things you want to scale in the way Google App Engine allows you to scale, and put that in Google App Engine. And then maybe you can put other things on EC2 or whatever, or in your own local system, and then combine them to get a more interesting result. It's very easy to get started, and it's really a very powerful platform, and it's been fun playing around with it. And as far as I know, everyone is free to get an account now, so it's just go ahead and play with it and create something really interesting. And now I think I can take questions. Are there any questions? Yes. There are microphones in the aisles. I can repeat your question if you really don't feel like going there, but we need to get it recorded. So, yes.
What should we be using Ioke for today in our application development?
You should use it for fun. It's not production ready. It's an experiment. I aim for it to be able to do real production stuff sometime in the future. But right now, what it's really good at is real expressibility. When you need to do internal DSLs and stuff like that, for example, it's pretty good at. But it's more of right now, it's more of the proof of concept stage where I hope that other language designers might use some of the features that I have designed into Ioke. Yes.
In summary, you can use Ruby on Rails with JRuby, right? So, in summary, what are the pieces, all the pieces I need to use Ruby with Ruby on Rails? I'm a little unclear on that.
What are pieces you need to use Ruby on Rails?
Are there any other pieces? I mean,
well, on Google App Engine or in general.
I create a Ruby on Rails application on my hard drive.
Mm-hmm.
Bingo, that's where it's at.
Yep.
Using JRuby.
Yep.
Okay, at that point, what do I have to do to make it all run in the cloud?
Well, basically, you need to download the SDK from Google App Engine.
Right.
And you can, and you also need Warble, and I think that's the only things those are the only things that you really need.
Okay, and I've got about 200 megabytes to play with in terms of file size. Is that it?
Sorry, 200 megabytes.
You say that Rails, of course, takes up about 800 files, right? So I've got about 200 to play with.
There are ways around that. You can YAR the gem files, so you won't get up to those high numbers immediately.
Yeah.
And you'll also get better speed if you jar them up. So that's definitely the recommended way. You basically just package the gems, the Rails files into jar files, and then they won't take up as many numbers.
Okay.
Yes.
If JRuby is really a more powerful and quicker implementation of Ruby, why, in general, not necessarily in the scope of Google App Engine, why would you not ever deploy an application on JRuby, a Rails application on JRuby?
Why you would not deploy a Rails application on JRuby? I have no good answer to that one. In general, no, actually, I mean, that sounds very glib, but the thing is that JRuby is really the best deployment platform for Rails. Period. What does Rich say? Rich has one of the longest running JRuby and Rails applications around.
I think one of the big reasons is, I think there are gems that don't exist on JRuby, like implementor, for instance,
Okay, so for the record, so what Rich is saying, one of the main reasons is that there are some gems that don't exist for JRuby. Specifically, those gems that depend on native extensions need to be ported in some way to use equivalent Java features.
I'm also going to answer this one. It is the best deployment platform, but you will run into things. Like, for instance, a lot of the very Ruby way of doing things, you have to kind of change the way of thinking when you move into JRuby. Like, for instance, you're threading now instead of forking. So no more globals, no more globals. Ruby people love globals. Don't do it. And just a lot of little things like timeout not working correctly is going to screw you in some places, stuff like that.
Yes?
So you'd mentioned that running C extensions isn't currently possible. And Charles Nutter in his RailsConf talk talked about ways that you might be able to eventually deal with that. But I like to look at that as an opportunity to rewrite those extensions in Java. And I was hoping that certain things I've run into in the past, for example, running mechanize, and then hprocot comes and it starts parsing and it does a seg fault, and I can't catch it, I can't log it, I have no idea what happened, and my server dies. I'm hoping I can catch those exceptions and do more logging. And isn't creating Java extensions actually a solution to the problem?
You are absolutely right, except that it's a question of scale. Most people that create C extensions nowadays actually have started to provide Java equivalents for JRuby 2. But the problem is all those, like, I don't know, we're talking probably thousands of C extensions that existed before JRuby. And no one is really in the right mind trying to port all of them to Java. But for the ones that are used, we try to port them. I mean, hprocot is a good example of a place where we have ported it to use use Java instead. Yes.
Does rake test work on the local development server?
Sorry?
Does rake test command work on the local?
See, that's a good question. I've heard that it works. I never got it working. Okay. I basically never got JRuby running Rails locally working very well.
And you were talking about running the actual test on the App Engine proper. How do you go around the lack of production test and development data store? So while you're running your test, you'll be basically using the data store that's in the Google, which would be the same as production.
There's not one data store. The data store is versioned exactly like all the other stuff. So if you deploy to one version of App Engine, you will actually get a specific, all the keys and all the stuff you can reach from that instance will only be those that you can reach from the same version. So if you deploy to test, you will only have, basically it's like having totally separate data stores. No more questions? Okay, thanks for your attention.